Good evening, all. I'm Deepak from Velmenni, and here I'm in front of you presenting my idea. So, what we are doing? We are working on a new wireless technology where we are sending data through visible light, which means we want to turn the light bulbs into a Wi-Fi hotspot with 100 times faster speed than the current Wi-Fis. We want to turn the optical fiber network into a wireless system. So the question is, do we require this technology and why we need this? I belong to a country which have 1.2 billion people. And in my city, I have 15 million people. Due to the large number of people, and everybody uses smartphones, everybody uses mobile phones there, we have limited spectrum with the radio frequencies, which is getting filled up soon. Due to this, we are having call drop issues. We cannot access the Wi-Fi's properly, and the issue just came now, so it doesn't work efficiently. So we need something which can solve this issue. You might have noticed in Slush, you might have tried to access the public Wi-Fi here, but due to the crowded area, crowded people, you cannot access it properly. Sometime it works, sometime it doesn't work. So this is the technical issue, which cannot be solved with the radio frequencies. So we need some technology which can solve this. So there is some other issues with the current wireless system. We cannot use it in aviation industry. We cannot use it in medical healthcare. Plus, it doesn't work in a noisy environment. So yeah, these are the issues. So we came up with a solution where we can provide at least 100 times faster speed than the current Wi-Fi's. So if you want to download a high definition video, you click on it and it will be downloaded in few seconds. The light has a much wider spectrum, so it solves that bandwidth limitation issue. Then we have light is freely available. We use light every day, so there is no need to license the spectrum. Where in RF you have to license the spectrum, so that's another advantage. And we can provide evenly spreaded data access, which means if you are here at every point of time, you'll have the same signal strength. So what we have done with this technology, we started 2 years back, and this year in January, we got our real working prototypes where we have sent data from one point to another point with 1 Mbps speed. Right now, we got 10 Mbps speed, 10 megabits per second, and we can send data up to 30 meters. And we have implemented a wireless mesh networking protocol, which means if you want to send data up to a mile or more, you can have multiple links in between, and we can send data up to a mile. So that's what we have done. And you can even transmit high-definition videos through our link. What is the real use case of this technology? The first, simplest use case is in Slush. We can provide a wireless network or internet access through light. That's it. The second would be we can do one mobile tower to another mobile tower communication through light. And we can solve the mobile backhaul problem for network providing companies. Another would be in the aviation industry. Inside a plane, we can create a communication system. We can create a flight entertainment system, and you can access internet inside a plane through the light, which is above the seat. And finally, we'll come into consumer space and we'll provide a high-speed data access in your homes. So yeah, we do have some competition. There are many research labs who has done similar research in this technology. We have like similar speeds, but we have integrated the mesh networking protocol, which means we can send data for larger distance. Here's the team. We are the guys from India, pretty young team, but we are from the best institute, engineering institute from the country, and having a research background. Before that, before starting this, we have created several products for different companies and clients, and we have solved one of the biggest traffic lighting issue in India. We revamped the whole traffic lighting system in New Delhi, which is the largest city, and have 10,000 signals. So the whole system is developed by us. So that's the team. And yeah, thank you so much for the pitch. And you can ask me questions about this technology and about the future of this technology. Thank you so much.
Thank you very much. I'm pretty impressed. You're sort of pretty scrappy, obviously already doing deals in India and so on, and a very innovative sort of solution that you're providing. So you obviously have a pretty smart team.
Yeah.
I'm going to ask something that's a little bit, I need to dumb it down a little bit here for me. So what level of light do you need? I mean, is this room good enough? You know, and then I keep thinking, what's going to happen to the poor people in Finland and Sweden when it's dark outside? Are they, you know, they're going to have to stay indoors all day to sort of get this to work. How does that work?
It's pretty interesting. Recently, we have used only single 1 watt LED, which gives you very less light. You cannot even see it properly, and it sends data. So we can dim the light to a certain level, which doesn't require much energy and can send data. But we can utilize the same light for illumination. If you want to like have light in your room, you can use much higher light and can send data. So it basically doesn't require any energy. It's very less. We can do it at 1 watt, less than 1 watt power.
So I want you to pick up on 2 things in your technical description.
Yeah.
One was 90% accuracy.
Yeah.
So just talk a bit about data loss and.
Yeah. So there are 10% data losses.
Sorry. And second thing was the hardware device. So can you just talk about the implementation and what we need from a user standpoint?
Yeah. Sure. So we created a hardware device, which is we call it node. So it can receive data through the light and it can transmit it again. So we created 2 systems. One is it's kind of a LED driver, which can drive any external LED bulb, and it turns into a data transmission system. On the mobile end, we created a very small device. You plug it to your mobile phone, and there is an app which can receive data. Apart from it, we can also receive data from the mobile sensor. We already have a light sensor inside a phone, but in that case, the speed is very less, in few kbps. So for higher speed, we need our hardware device.
Got it. And what happens on the building wiring side? Like what needs to happen in terms of backhauling that data or getting that data out?
In that case, how it works, we have a standard router. You can plug the LAN cable, which is coming from the ISP, to the router. And then it creates a light network using the light only. So all the bulbs communicate with each other, and then they send data to us, basically.
This kind of infrastructure can be used in lots of different places, as you displayed. Which sector would you begin with? What's the best customer sector?
We already have started working with, on different pilot projects. So we feel that in industrial environments, in industrial automation, that's the first application we can utilize the technology. Because RF system doesn't work there efficiently. It's a huge market which requires a data communication, wireless data communication. So industrial automation, industrial internet is one of them. So that's the first market that we are going on. And then we want to move on. We want to do some more pilot projects where in the crowded areas, in the office spaces, we can provide a very good, evenly spread data access. So in any company where a lot of people are working in an open area, using the same light, because we use light all the times inside the building. So we can provide a good data access. That's another application, the second thing. So we'll go for that.
All right. That was what we had time for. Thank you very much.
Thank you so much. Thank you so much.